So using the steps in solving logarithms, we're going to apply them to these questions here. Solve for x, round your answer to 3 decimal places, and keep in mind you do need to check your answers because they're log equations. You can't have a value of x coming in here that's going to make the argument negative. So the first thing is to isolate the logarithms. We've got that done. We've got logs on one side, number on the other. Condense, so we've got to add the 2 logarithms. So we're going to make it into one log base 10. Go ahead and write the little 10 in there. Because there's no subtraction, this is all multiplication, straight across, x plus 8 times x minus 1. This needs to be FOILed out. So you're going to take the first times the first. We get x squared, and then first times first, and then we're doing the outside, x times negative 1, positive 8 times x, and positive 8 times negative 1. All right, from here, combine like terms. So we have log base 10 of x squared plus 7x minus 8 equals 1. We need to solve for x, and we need to get rid of the word log. So to undo a logarithm, we write it as an exponent. So we take the little baby base that's here, and that becomes the big base of my exponent. 10 to the power 1 equals x squared plus 7x minus 8. 10 to the 1 is just 10. And it becomes a problem much like on the previous page. We have a quadratic equation, degree 2. So to solve it, we're going to set it equal to 0. And then it's your choice as to if you want to use the quadratic formula and you remember that, or if you want to factor. So subtract 10 from both sides, set it equal to 0. You should be able to factor these. So we're looking at what's going to multiply to negative 18, but then add to positive 7. So we're looking at a 9-2 combination for 18. But we want a positive 7, so it's going to have to be a positive 9, negative 2, positive 9, negative 2 to give me the negative 18. So when I break this down into my 2 parentheses to get x squared, x times x, and then positive 9, negative 2. If you FOIL that all out, you're going to get back x squared plus 7x minus 18. This idea right here, though, only works if there's a 1 in front of the x squared. If there isn't, then we're going to have to do something slightly different, and I'll show you how to do that when we get there. Set each of these factors equal to 0, solve for x, and then check your answers. So subtract 9, add 2. We're going to be a little suspicious of this negative answer here. If I take x equals negative 9, and plug the negative 9 back into either one of these. It doesn't matter which one, but if either one of them comes up a negative argument once we've computed, we can't use it. So I can see right away, negative 9 minus 1 is going to be a negative number. Can't use it. Doesn't matter what happens elsewhere. If it fails once, the whole thing is done. If I plug in the number 2, 2 minus 1, that's 1. 2 plus 8, that's 10. As long as it's positive, it's good. Right, so that one only had one answer. If they both would have come up a negative argument, then we would have had no solution. Right, so for part B, same idea. Condense. So it's going to be log base 5 of 2x plus 1 times x plus 1. FOIL it out. So 2x times x, 2x times 1 times x, and then 1 times 1. Combine like terms. So the 2x squared didn't have anything to combine with, but the 2x plus 1x will add up to 3x. And now get rid of the log. So to get rid of a log, I need an exponent. I bring the base down. 5 to the 0 equals 2x squared plus 3x plus 1. 5 to the 0 power, though, is 1. So that's 2x squared plus 3x plus 1. Set it equal to 0. So I have 0 equals 2x squared plus 3x, because these cancel out to 0 as well. This one only has 2 terms in it, and they both have an x in common. So do the common factor first. Pull that out. You can pull an x out of both of them. And then x times 2x will give me the 2x squared. X times a positive 3 gives me the 3x. Set each factor equal to 0. And then solve for x. Well, this guy's already solved for x, so I don't have to do anything there, but this one I'm going to have to subtract 3 first, then do your division step at the end. So x equals -3/2, or -1.5 if you want to go that way with it. But leaving it as a fraction is good enough. But the thing is, I've got to check my answers. So if I plug the number 0 back in here, 2 times 0 plus 1, positive number. 0 plus 1, positive number. So x equals 0 is good. But if I take -3/2 or -1.5, it might be easier with -1.5. -1.5 plus 1, that's going to turn into a -0.5. And we can't have a negative argument, so neither of that solution is going to work. And our only answer is x equals 0. Kind of the same thing going on with part C here. Combine them with a plus sign, we're multiplying. So I have x plus 3 times x minus 3. Multiply that out. These are conjugates of each other, the same numbers but opposite sign in the middle, which means their middle term is going to cancel out. I'm going to get a plus 3x and a minus 3x. So I'm really only going to get multiply the first times first, and a positive 3 times a -3, because the other two numbers, plus 3x and minus 3x, will cancel. Rewrite the logarithm as an exponent. Get rid of the word log, bring down the 4. So I have 16 equals x squared minus 9. Set it equal to 0. And I get x squared minus 25. Now, these two don't have anything in common like my other problem did, but I can factor it. That's the difference, the subtraction of two squared terms. So if I write down my two sets of parentheses, to get x squared, that's going to be x times x. To get a -25, signs are going to have to be opposite, 5 times 5. Set each factor equal to 0. Solve for x. Again, we've been a little suspicious of the negative answer, so let's try that one first. -5 minus 3. If I plug it right back in here to this second argument, it gives me a negative result. I don't have to check it any further. But if I take the positive 5, 5 minus 3, that's 2. 5 plus 3, that's 8. So as long as those answers are positive, we can use that as our solution. For letter D, we only have one logarithm in here, but we still need to get the log isolated. So in other words, the 5 has got to move to the other side. So I have natural log of 2x plus 3 equals 3. Remember, ln is the same as log base e. And the reason I need to know that is because I need to get rid of the logarithm, ln or log base e. Either way, I bring down the base, raise it to the power, set it equal to 2x plus 3. All right, now this is where I'm going to need my calculator. Take e to the third power, and it's going to come out about 20 point, and then there's a bunch of digits. 0, 8, 5, 5, 3, 6, 9, whole bunch of other digits, equals 2x plus 3. I still need to solve for x, so I'm going to take away 3 from both sides. And if you've got that number on your calculator, you can just hold it and do the calculation. So in other words, I'd come in here and do e to the third, get my big long decimal. Now I want to subtract 3, so I'm just going to hit minus 3. So I got the 17 point whole bunch of digits. I don't really need to write them all down, just hold them on your calculator. And then my last step would be divide by 2. So again, if I've got that number on my calculator already, all I have to do is hit divide by 2, and I get 8.54. And they wanted it round to 3 decimal places. So 1, 2, 3, draw your line in, and then look to the right of the line. 7 is bigger than 5, so I bump the 2 up to a 3. So x is equal to 8.54, and then that got bumped up to a 3.